so you guys are probably want to get ready to like drop the answer in the chat once you have them. Okay, so multiplying by 25. So the easier way to multiply by 25 is to divide the number by 4 and multiply by 100, because 100 divided by 4 is 25. So since multiplication and division are interchangeable, it's possible for you to do this. So for example, if we have 36 and 25, that is 90. Or 900, sorry. Because 36 divided by 4 is 9, and then you can multiply by 100 to get 900. And then with 50, it's the same concept, but you divide by 2 instead. So you can take whatever number you're multiplying 50 by, divide it by 2, and then multiply by 100. Like that. So 72 times 50, you would just look at 72, divide the number by 2, get 36, and then your answer would be multiplied by 100. I'm sorry, I think the transitions went opposite, because these are supposed to be covered, but it's okay. For number 70, this one, divide the number by 4, then multiply by 3, and then multiply by 100. So this one takes a moment to think about when you look at it at first, but dividing the number by 4 and then multiplying by 3 is the same thing as multiplying by 3/4, and 3/4 of 100 is 75. So it's the same thing as multiplying by 75. The question is, what is 24 times 75? So 24 times 75. Can you guys try that really quickly? Because if I click, it'll show the answer at the same time. Once you get the answer, just put it in the math general discussion.
And it's okay if you get it wrong. It's just for practice. So just go ahead and try it out.
Yeah. Tell us what you get, even if you think it's wrong. We'd rather see you try than not try at all. Okay, so 24 times 75. I don't know your name is, but someone says 1800. Okay. Let's see. What else do you guys think? Okay, Monchi says 1800. Let's go ahead and check and see what the answer is. Okay. The answer is 1800. Good job. So pat yourself on the back. And then the last one is 125. So for this one, you divide the number by 4, add it to the original, and then multiply by 100. So when you're dividing by 4, it's the same thing as taking 25, and then you add one of itself. So 125 is 5/4 of 100, and 5/4 is 1 1/4. So you can take itself and 1/4 of the number you're multiplying by to get 5/4 of 100. So try 44 times 125. That's the next one. Oh, and I think someone just joined, so I'll say it again. So try 44 times 125 with that same concept. Okay, I see one answer. Good. Okay. It looks like most of you guys are coming to agreement, so let's see. You are correct. Oh, it's kind of blocked. I'm sorry. Here, I'll escape. Oh, maybe this time it'll show up the right way. Give it a moment, it has to load. Okay. But you guys are correct. It is 5,500. So, good job. Okay.
Okay, so one aspect of multiplication we did, and we also had some more multiplication review. So the first one is times 11. So for this one, what you want to do is whenever you see a number times 11, you want to take that number that's being multiplied by 11 and write down the last digit of the number. So once you write that down, you want to then write down the sum of the last and the next digit to that. And then you just continue that pattern for the rest of the numbers until you are left with the leftmost number, and then you just write that down to finish it off.
Okay, so the questions for this were 37 times 11. That was the first one. "37 times 11. If you know how to do it, go ahead and say it.
Or wait, do you want to go over the first example and then we can have them do the second one?
Yeah, sure. I'm fixing the animation really quickly. It'll take like a second because they went the opposite direction.
Okay.
Like it fades in instead of out, so I'm just fixing that. Here. Should be fine now. Okay, now the questions appear. So the first one, 37 times 11.
Okay, yeah, so I think, yeah, we'll go over this one, but then you guys can try example 2 for times 11. So, yeah, so for the first one, the answer is 407. So what you first wanted to do was, since you're multiplying 37 by 11, you want to first write down the 7, and that's your first step. And then you just take the sum of the first number, so 7, plus the last number, or the number next to it in this case. So that would just be 3 plus 7. Now notice, usually this won't happen, but in this case, since it's a 2-digit number, you only want to write the 1 digit of the sum. So since it was 10, you want to write down the 0, but then you still want to keep that tens digit or 1 in mind since it's a 2-digit number. And so you want to carry that over whenever you write the last digit or 3 down. So so 3 plus 1 is 4. So that's what. Now just continue that same pattern for 226 times 11. It's the same concept, you'll just have an extra step.
Okay, someone says 2,486. That sounds reasonable. Okay. It looks like most of you guys are in agreement, so I'm just going to go ahead and review.
Yeah, so yeah, you guys were right. So yeah, for this one, you just write down the 6, add 2 plus 6 to get 8, add 2 plus 2 to get 4, and then write down the very first digit to get 2. Okay, so for times 101, this is actually really easy. Whenever you see this on a test, it's basically a freebie. So all you have to do is, and it only works for 2 digits, so if you have a 2-digit number times 101, all you have to do is just write the number twice. So yeah, so go ahead and try 88 times 101.
Okay.
Yeah, that one's really easy. And then, yeah, for number 7, or for times 101, it's also really simple. But this one, there's a trick for 2-digit and 3-digit. So for 2-digit numbers times 101, all you have to do is just repeat the number, but you want to make sure to add a 0 in between the two numbers. So if you were doing 88 times 1001, then you would still repeat the two numbers to get 8888, but then you would want to add a 0 in between. So it would be 88088. And then if you have a 3-digit times 101, then you just write the number twice. So yeah, try those two.
I'm going to go ahead and reveal, since it looks like most of them got it.
Yeah. So yeah, 63063, and then just repeat the number twice, 456, 456.
Good job.
Wait, is it Ramesh going over this, or is it me?
So we have multiplicative and additive inverses. This is quite simple. Multiplicative inverse is also known as the reciprocal, where you get a fraction of a number. So let's just say you had 2/3, and then you basically flip the numerator and the denominator. So instead of 2/3, it would be 3/2, or 3/2. If you have a non-fraction, let's just say 7. So 7 can be turned into a fraction, which is 7/1, which means 7 whole parts. So you just flip that, and then you get 1/7 as your reciprocal. This works with negative numbers as well. And then your additive inverse is basically multiply the number by -1, and then you have your additive inverse. So additive inverse of -15 is 15, and the additive inverse of 5/8 would be, -5/8. So memorizing squares, we highly recommend memorizing squares. It really helps, especially for you people in number sense. But you can decide not to memorize squares as well, where there are a few tricks. For example, if you're just fast at doing math, you can basically do 10 squared, 30 squared in your head, not that hard. And then there's one more trick where squares are always the sum of odd numbers. So let's just say you have 1 plus 3. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 would be 16, and so on. So those basically add up to perfect squares. But it is recommended to memorize them, because if you do have them memorized, it's going to take you, 2 times less time than actually doing the math. But if you do the math quick enough, it shouldn't really be a problem. And then the next slide is cube memorization. So again, it's really recommended that you do memorization of cubes. But if you know your squares, you basically multiply. Let's just say you have 12 cubed. So you have 12 squared, and then you multiply that by 12, which isn't that hard. But again, it's faster to have it memorized. So squaring any number with 5. So you have, let's just say 25, as they have. So, oh, actually 65. So you have 65 times 65. So you notice the 5, you write down 25, and then you multiply 6 by 6 plus 1. So 6 times 6 plus 1, 6 plus 1 is 7. So that would be 42. because 6 times 7 is 42. So that's the other side of your numbers. So it would combine and become 42. You'd write down 42, and then you'd write down 25. So it would be 4,225. Squaring any two-digit number. So I don't think my explanation completely lines up with this, but what I was taught is, do you guys know how to square? Do you know what a squared plus 2ab plus b squared is? Just a question. Um, no? Okay, so
We have a slide for that if you want me to, I can find it in a different.
I think I can explain it verbally.
That's okay.
So if you have a number, can I share my screen?
Yeah, go ahead. You guys go ahead and Ramesh is about to share a screen. Just go ahead and drop into his stream really quickly once he does.
So you have what? You have number A plus number B squared. Squared. So this would be equal to A squared plus 2 times A times B plus B squared. So you can use this trick for this. Sorry. So you have two-digit numbers, right? So you basically, let's just say you have what? Their example is 29.
Wait, use a different one
so
they can use that one.
Oh, okay, cool. Let me erase this. Actually. So, let's say 47, because that's a nice number. So you basically split it. So 47 is equal to 40 plus 7, right? So you'd have 40 squared, which, knowing your multiplication table, should be 1,600 plus 2ab, so 2 times 40, which would be 80, times 7, which would be, sorry.
560.
Yeah.
Yeah, you got it. You got it.
Plus b squared, so 7 times 7, knowing multiplication tables again, would be 49. And you basically add all these up, and yeah, you have your square.
Yeah, so that was like quadratic formula concept applied in this scenario. You'll probably learn that if you're in algebra, you're probably gonna learn that like sometime next semester, like near the end.
Yeah. And what Ramesh said is entirely correct because what we have here is the exact same thing, but it's just written in verbal form. But if you remember it the way he does, it'll probably be easier for you, especially if you already know algebra. So you guys can go ahead and try 29 squared and tell us what you get. Okay. Someone has an answer. Okay, close. But think about whether your answer is reasonable. Or sorry, never mind. I read that wrong. Okay. Two.
So, a nice way to check this is you do not saying whether the answers are correct or incorrect, but a nice way to check it is you have oh wait, the slide just glitched out, sorry. You have the A value, right? So you split, let's say again 47. So it has to be a reasonable distance from the A value squared because that's the largest value you're inputting into it. So just a thing.
Okay, but yeah, I'll go ahead and reveal the answer. And you guys are correct, so good job.
Is my okay, there we go. We're gonna go over Roman numerals as well, and you guys might want to write these down for the examples that will be shown later on. But basically, I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. When you're using these to write numbers, you can't write more than 3 in a row. So if you have 3 I's in a row, that's fine, and that would be 3. But if you have 4 I's in a row, you can't write it like that. And you also have to group letters that are the same together. So for example, I, you can't have the 2 I's on opposite sides. You would do VII or IIV depending on what number you're trying to represent. And if 2 symbols like LL can be represented with another letter like C, then you would write it as C instead of LL. So instead of writing 4 I's together to represent the number 4, you would place a smaller Roman numeral before a greater Roman numeral. So for 4, you would put 1 in front of, or the I in front of V, which is 1 before 5, which is 4. So an example is CLI. Do you guys want to, and then MMXC and XLI.
Here, we'll just go one at a time.
Okay.
Does anyone else have an answer? So yes on the 151. Good job. I'm just gonna keep going. Okay, feel free to just solve the rest of them if you guys already have them. I know Jessica has done 2 of them. Good job, 2090. And then 41. Yay!
Sometimes the tests will ask you to convert these into Arabic numerals, but Arabic numerals are just normal numbers, so you would just do what you just did when it asked that. You can also perform operations on Roman numerals like adding, subtracting, multiplying, and dividing them. So for example, mm minus d, that would be 2000 minus 500, which is 1500. And then ix times c, which is 9 times 100, which would be 900. And on the tests, mainly it's just addition and subtraction. And you can try the exam.
Let's do like 1 through 2, so we don't have like different answers floating around. Do 1 and 2, and try to number your answers so we know which one you're talking about, since there's a lot on this slide.
Yeah. And you guys can also send all your answers at once you don't have to, like, instead of pressing enter to go to the next line, just press shift enter and it won't send a message, but it'll just go down to the next slide or next line. That way you can just write all your answers in one text message.
Okay, I'll go ahead and reveal 1 and 2, since it looks like most of you have it. So yay, most of you guys I think all of you got it correct. Okay. Did the rest of you guys get anything for the last one? Because I see one answer from Jessica, but the rest of you haven't answered. So, should I just reveal the answers?
Yeah, I think go ahead, just reveal them.
Okay. See, good job. And if any of you were confused, this one is 10 times 14, and this one is 1,000 plus 500 and 200, so that makes 700, and then this makes 9 because it's a 1 in front of a 10. And then this one is just 1,000 divided by 500, so you get 2. Okay, PIDs. If you're wondering what PIDs are, they're positive integral divisors. All the numbers that can be evenly divided by a specific number. For example, 2 is a PID of 4, 1 is a PID of 4. And another example would be like 50 is a PID of 100 because it's a factor of 100. So, for instance, 28 has 6 positive integral divisors, and we just say PIDs because it's much shorter than having to say the entire long title. 1, 2, 4, 7, 14, and 28. We count 1 and the number itself too. And when you see this type of problem, there's a much easier way than having to count all the factors one by one. All you need to do is take the prime factorization of the number, and then you add 1 to each exponent, and multiply the added exponents together. So if that doesn't make sense, an example is probably going to. So if you're looking for the number of PIDs of 54, if it asks you on a number sense test or an A+ math test, because it does show up on both, 54 would be 2 times 3 cubed, which is 2 times 27. So this is the prime factorization. And we know the exponent for 2 is an assumed 1. We just usually don't write it. So 1 plus 1, and then for 3, the exponent is a 3, so we'll add 1 to it and we'll multiply it together to get 2 times 4. So then we know there are 8 positive integral divisors of 54. So now it's your turn. Find the number of PIDs of 1000. Yeah, I can go back. So 2 and 3, are you talking about the 2 and the 3 in the prime factorization? Okay, so prime factorization is when you simplify a number down to where it's only made up of prime factors. So 2 is a prime number, and 3 is also a prime number. These two numbers you can't break them down into factors any further. So this is the prime factorization of 54, and that's how we find the number of positive integral divisors in a simpler fashion. So usually, if you're on an A+ math test, I like to just make a number tree, or you can just divide. So if you know 54 is divisible by 2, you know one of its prime factors is 2. And if you divide by 2, you get 2 times 27. That's what you get to get 54. And you know 27's prime factorization is 3 cubed. So then you know the prime factorization of 54 is 2 times 3 cubed. And then step B. Okay, yeah. So on an earlier slide, I'm going to go back. After you take the prime factorization of the number, you add 1 to each exponent, and then you multiply the exponents together. So in this case, with 54, the prime factorization is 2 times 3 cubed, because 2 times 3 cubed is equal to 54. Then you add 1 to each exponent. 2 has an exponent of 1 because 2 is just 2 to the first power. So then you do 1 plus 1, and that's one factor you multiply. And then with 3 cubed, the exponent is a 3, so you would add 1 to it, and then you multiply to get 2 times 4. Okay, I'm glad that makes more sense. Don't be afraid to stop me if it didn't make sense. $16. Okay, that sounds promising. Did anyone else get anything? Alright, I'm going to go ahead and reveal the answer. So 1000's prime factorization is 2 cubed times 5 cubed. Because this is 8 times 125. So then we can double check our work and see that this does multiply to get 1000. And 2 and 5 are both prime factors, so we can't simplify this any further. So we know we have the prime factorization. But an easier way to derive this one, since this one, 1000 is just 10 cubed, you could take the prime factorization of 10 and then cube each factor to get it, and it'd be the same way. So if you have 2 cubed times 5 cubed, we add 1 to each exponent. So in this case, 3 becomes 4, and then you add 1 to 3 here, and then 3 also becomes 4. So you have 4 times 4, and so then there are 16 positive integral divisors of 1000. Good job.
Okay, now some questions will also want you to find the sum of all the PIDs. So before you found how many PIDs there were. In this one, you're going to take all those individual PIDs and then add them together. Now that's that's a lot, so there's a much easier method to do that. So first what you want to do is, again, take the prime factorization of the numbers. So yeah, prime factorization is a pretty important concept for finding the sum and finding the number. And so once you have the prime factorization, if you want to look at the individual numbers and take notice of their exponents. So if the exponent is 1, all you have to do is just add 1 to the base, and it'll make more sense when I go over an example. And then if the exponent is greater than 1, you want to do the following formula, and so that's n is just the number to the exponent plus 1 minus 1 divided by n minus 1. So looking at the example, so let's say you're asked to find what's the sum of the PIDs of 28. So first, just start off with taking the prime factorization of 28 to get 2 squared times 7. And then once you have the prime factorization, you want to take a look at the individual numbers. So that's 2 squared and 7. So starting with 7, you know it has an exponent of 1, right? And looking at step 2, if an exponent is 1, then all you have to do is add 1 to the base. And the base is just the 7. So that would be add 1 to 7 to get 8. And that's one of your numbers that you need to find the answer. Now you want to look at 2 squared. So looking at 2 squared, 2 is greater than 1. So now you want to do this formula right here. So that's just, so you just plug in 2 for n and then just follow the formula. Oh wait, yeah. So then you follow the formula throughout. So looking at step 3, you just do 2 to the 2 plus 1 power minus 1 and then divided by 2 n minus 1 or 2 minus 1 to get 7. So yeah, you probably want to just like write that down and just have it for reference when doing the problems. And so you basically want to do that rule. So like you want to do steps 2 and 3 depending on what the exponent is for all the individual numbers. So since this one only had 2 individual numbers, 2 squared and 7, you just had to do it twice. And so once you get the number or the answer for each of the individual ones, you just take them. So first you got 7, and then for step 3 you got 8. The last step is just to multiply those two numbers to get 56. So try this one. Yeah, it may be a bit confusing at first, but yeah, Olivia, could you go back to the next to the slide before? I think they wanted to take a picture like the formula.
Yes, I can. Give me. Hey, Laksh.
Mm-hmm. Oh, yeah?
I think we should finish after PIDs and then finish up series next time because it is near 5 o'clock.
Yeah, yeah.
Okay. Should we go ahead and reveal it then?
Yeah, I can just go over this one since it's yeah. So it's asking for the sum of PIDs of 20. So first you want to just take the prime factorization. So that's 2 squared times 5. And so then you want to do the steps 2 and 3 for on last slide. So you want to look at the individual numbers 2 squared and 5 and just apply those 2 steps. So looking at 5, you notice that it has one exponent, right? And whenever it has one exponent, it's really easy. All you have to do is add 1 to the base, which is 5. So that's one of the numbers, so you do 5 plus 1 and that's 6. So that's one of the numbers in the product. And so then you want to look at 2 squared, and you notice that it has 2 as an exponent, which is greater than 1. Then since it's greater than 1, you have to use that long formula that was on the last slide. And then you should get some number after that formula. And then once you get both of your numbers, so in this case 7 and 6, you would then multiply them two together to get 42. And so 42 in this context means the sum of all the PIDs of 20 is 42.
Okay. There's a second method to do this, and this will be the last thing we go over today. So you also would find the prime factorization. As we've seen, prime factorization is kind of important. And then you add the prime to the highest power in the number to one that is smaller by it until the exponent reaches 1. So for example, if you had 2 squared, you would take 2 squared plus 2 plus 1, because that's 2 squared plus 2 to the 1, and then plus 2 to the 0 power. And then you would multiply each one for each prime factor altogether. This might make more sense if you look at an example first. So 30. The prime factorization of 30 is 2 times 3 times 5. Pretty simple. 6 times 5 is 2 and 3, 6. So the way that you would find the sum of the positive integral divisors, you take 2, and so the highest power we have for 2 here is just 2 to the 1. So then you have 2 to the 1 and 2 to the 0. So you add up all the powers of 2 from the highest one you have all the way down to 0. So here, since we just have 2 to the 1, you subtract 1 and you get 2 to the 0. And so you multiply 2 to the 1, and 2 to the 0 with 3 to the 1 and 3 to the 0, because we see that 3 is also only to the first power. And so the only powers that are below 3 to the first are 3 to the 0. And then the same for 5 to the 1. So then we get 2 plus 1 times 3 plus 1 times 5 plus 1. 3 times 4 times 6, and we get 72. So you guys can go ahead and try the next one with 24. And this is the same thing. It's pretty similar to the last one. In reality, if you use geometric sequences to derive the formula. But this one might be easier for you to think about. It just depends on which one you would prefer working with. Okay, I see two very different answers. So let's just figure out which one's right or closer, if none are. So 24 can be represented as 2 cubed times 3 because this is 8 times 3. So then if we look, 2 cubed, all the powers that come after 2 or 2 come before 2 cubed are 2 squared, 2 to the 1, and 2 to the 0. And then with 3, we just have 3 to the 1. So we can add 3 to the 1 and 3 to the 0. And if we solve, we have 8 plus 4 plus 2 plus 1 times 3 plus 1. And when you solve and multiply, you get 15 times 4 and 60. So good job. Some of you got that right. Okay, one last example before we go.
Or should we still need to go over like the new activity, so should we just skip to that?
Do you want to wait till next week, or do you want to do?
I think we should probably go over the activity this week, but then we can go over sequences next week.
Sounds good. We're gonna skip this example. We're just gonna go over this really quickly.
Okay, yeah. So I don't think we have any other Kahoots for this game to try to just to make a bit more unique in terms of like activities. So we have this new one called, and it's a group practice game. And for this one, it's a new game that involves teamwork. And so basically there will be two teams, and you'll split into two separate voice channels. And so the mentors, us, will screen share a practice test, and then we'll also like give you guys a document to work on. And in that document, you guys will basically just see the practice test that's being screen shared, and you'll work together to answer as many questions as you can within a certain time limit. And I think it'll usually be 15 minutes. And so with this one, teamwork is allowed. Like you're supposed to collaborate, and just to like, although in like a normal test you won't be able to collaborate, it'll be more individual. But just to make it fun, I think it'll be better if you guys work together. So then once the time limit's up, you guys, whatever work you've done, will score that based on the actual test scoring that's used in like the number sense and math UIL exams. Then the team with the most points at the end wins. And so that's how the new game works. And so yeah, so for this week, so we got to PIDs, but we skipped sequences since since we're running out of time. But we'll go over sequences next week, and we'll fit it into next week's workshop. So
That's all. Thanks for coming. You guys are free to go now.
Thank you.
Thank you. Bye.